A disconnect falls under the scope of Article 110 of the National Electrical Code, which covers general requirements for electrical installations. Section 110.26 specifically addresses the location and accessibility of switches and circuit breakers. A table placed under a disconnect can potentially create a safety hazard for a few reasons. Firstly, the table may obstruct access to the disconnect, making it difficult to operate in an emergency. Secondly, objects or materials placed on the table may come into contact with the disconnect or its wiring, creating a potential electrical hazard. Thirdly, combustible materials stored or placed on the table may ignite if an electrical fire occurs. Section 110.26 of the NEC requires that switches and circuit breakers be in sight from the equipment they control and readily accessible. It also prohibits placing objects or materials within 3 feet of the disconnecting means. To address the safety concerns raised by the table under the disconnect, it is recommended to take the following actions. 1. Relocate the disconnect to a location where it is not obstructed by the table. This will ensure easy access and prevent the table from creating a tripping hazard. 2. If relocating the disconnect is not feasible, install a physical barrier, such as a railing or fence, around the disconnect to prevent accidental contact. 3. Implement measures to limit access to the disconnect to authorized personnel only. This could include using warning signs or installing a lockable cover. By following these recommendations, you can enhance the safety of your electrical installation and ensure that the disconnect is readily accessible in the event of an emergency. Ensuring readily accessible electrical disconnects is a vital aspect of electrical safety in any facility. A disconnect is designed to quickly cut off power to equipment, offering a critical safety measure during maintenance, repairs, or emergencies. The National Electrical Code, or NEC, provides guidelines, particularly in Section 110.26 regarding the accessibility and working space around electrical equipment, including disconnects. Clear access is essential so that personnel can easily and safely operate the disconnect. Obstructions such as tables, storage, or fixed structures can impede rapid access, increasing the risk of injury or equipment damage in an emergency. Maintaining the required working clearances, as specified in the NEC, around disconnects is also crucial. These clearances provide enough space for electricians and other qualified personnel to safely inspect, maintain, and operate the equipment. The working space typically includes minimum depth, width, and height requirements, ensuring that individuals can perform their tasks without undue hazard. Electrical hazards are a significant concern when access to disconnects is compromised. Obstructions can lead to accidental contact with energized parts, increasing the risk of electric shock or arc flash. It's important to keep the area around disconnects free from conductive materials and ensure that proper insulation and grounding are in place to minimize these risks. Fire hazards can also arise if combustible materials are stored near disconnects. Overheating or electrical faults can ignite these materials, leading to a fire. Keeping the area around disconnects clear of flammable substances is a critical safety measure. Regular inspections of disconnects and their surrounding areas are recommended to identify and address potential hazards. These inspections should verify that the disconnect is functioning correctly, that there are no signs of damage or overheating, and that the required working clearances are maintained. Any identified issues should be promptly corrected to ensure the safety of personnel and equipment. When addressing accessibility issues around disconnects, several corrective actions can be considered. Firstly, relocating the disconnect to a more accessible location is a viable solution. This may involve moving the disconnect to a nearby wall or structure where it is free from obstructions and meets the NEC requirements for working space. Another option is to install physical barriers to prevent obstructions from being placed near the disconnect. These barriers can be in the form of railings, fences, or even simple bollards. They serve to clearly define the required working space and prevent storage or other items from encroaching on the area. In some cases, modifying the layout of the work area may be necessary to improve accessibility to disconnects. This could involve rearranging equipment, relocating storage areas, or creating wider pathways to ensure that personnel can easily reach the disconnect. Proper signage and labeling can also enhance safety by clearly identifying the disconnect and indicating the required working clearances. Warning signs can alert personnel to potential electrical hazards and remind them to keep the area clear. Regular training for employees who work near disconnects is also essential. This training should cover the proper operation of the disconnect, the importance of maintaining working clearances, and the potential hazards associated with the electrical equipment. By implementing these measures, facilities can improve the safety and accessibility of their electrical disconnects, reducing the risk of accidents and ensuring compliance with NEC standards. The National Electrical Code, specifically Section 110.26, emphasizes the importance of maintaining clear and unobstructed access to electrical equipment, including disconnects, to ensure worker safety and facilitate efficient operation during maintenance or emergency situations. Accessibility requirements include maintaining adequate working space around electrical equipment, as specified by the NEC. This space provides enough room for workers to safely inspect, maintain, and operate the equipment without being exposed to electrical hazards. The minimum dimensions of the working space depend on the voltage of the equipment and the layout of the surrounding area. Obstructions such as tables, storage, or fixed structures can impede access to disconnects and create safety hazards. These obstructions can make it difficult for workers to quickly and safely operate the disconnect during an emergency. They can also increase the risk of accidental contact with energized parts, leading to electric shock or arc flash. Electrical hazards associated with obstructed access to disconnects include the potential for electric shock, arc flash, and burns. Workers may be forced to reach over or around obstructions to operate the disconnect, increasing the risk of contact with live conductors. Additionally, obstructions can prevent workers from quickly energizing equipment in the event of an electrical fault, increasing the potential for equipment damage or fire. Fire hazards can also arise if combustible materials are stored near disconnects. Overheating or electrical faults can ignite these materials, leading to a fire. It is important to keep the area around disconnects clear of flammable substances to prevent fires. Recommendations for addressing accessibility issues around disconnects include, firstly, relocating the disconnect to a more accessible location. This may involve moving the disconnect to a nearby wall or structure where it is free from obstructions and meets the NEC requirements for working space. Secondly, installing physical barriers to prevent obstructions from being placed near the disconnect. These barriers can be in the form of railings, fences, or even simple bollards. They serve to clearly define the required working space and prevent storage or other items from encroaching on the area. Thirdly, modifying the layout of the work area may be necessary to improve accessibility to disconnects. This could involve rearranging equipment, relocating storage areas, or creating wider pathways to ensure that personnel can easily reach the disconnect. Fourthly, providing proper signage and labeling can also enhance safety by clearly identifying the disconnect and indicating the required working clearances. Warning signs can alert personnel to potential electrical hazards and remind them to keep the area clear. Fifthly, conducting regular training for employees who work near disconnects is also essential. This training should cover the proper operation of the disconnect, the importance of maintaining working clearances, and the potential hazards associated with electrical equipment. By following these recommendations, facilities can ensure that their electrical disconnects are readily accessible and safe to operate, reducing the risk of accidents and ensuring compliance with NEC standards. It's also worth noting that local jurisdictions may have additional requirements or interpretations of the NEC that must be followed. It's always best to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. A comprehensive approach to electrical safety, including regular inspections, maintenance, and training, is essential to protect workers and prevent accidents. The specific requirements of NEC Section 110.26 regarding working space around electrical equipment The NEC provides detailed guidelines for the minimum dimensions of a working space in front of electrical equipment depending on the voltage of the equipment and the layout of the surrounding area. These dimensions are designed to provide enough room for workers to safely inspect, maintain, and operate the equipment. For example, for equipment operating at 600 volts or less, the minimum clear working space in front of the equipment must be at least 3 feet deep, 30 inches wide, and 6 feet 6 inches high. The NEC also specifies the required headroom and lighting in the working space. There must be sufficient headroom to allow workers to stand upright without hitting their heads on overhead obstructions. Adequate lighting is also essential to ensure that workers can clearly see the equipment in the surrounding area. The NEC prohibits the placement of any obstructions within the required working space. This includes tables, storage, fixed structures, and any other items that could impede access to the equipment. The only exception is for equipment that is designed to be installed in a specific location, such as a panel board that is recessed into a wall. The NEC also addresses the issue of dedicated equipment space. This refers to the space above and below electrical equipment that is reserved for the installation of raceways, cables, and other electrical equipment. The NEC prohibits the use of this space for any other purpose, such as storage or the installation of non-electrical equipment. In addition to the general requirements for working space, the NEC also includes specific requirements for working space around specific types of electrical equipment, such as switchboards, panel boards, and motor control centers. These requirements are designed to address the unique hazards associated with each type of equipment. The NEC also includes requirements for the identification of electrical equipment. All electrical equipment must be clearly labeled with its voltage, current rating, and other important information. This helps workers to identify the equipment and to ensure that they are using the correct tools and procedures. Finally, the NEC includes requirements for the training of electrical workers. All electrical workers must be properly trained in the safe installation, maintenance, and operation of electrical equipment. This training should cover the NEC requirements for working space and other safety precautions. By following the NEC requirements for working space around electrical equipment, facilities can significantly reduce the risk of electrical accidents and injuries. A disconnect switch is a mechanical switching device used to isolate an electrical circuit or piece of equipment from its power source. Disconnect switches are typically used for safety purposes, to allow for maintenance or repairs to be performed on energized equipment. The NEC requires that disconnect switches be readily accessible and located within sight of the equipment they serve. This ensures that workers can quickly and easily de-energize the equipment in the event of an emergency. The NEC also requires that disconnect switches be clearly labeled to indicate the equipment they serve. This helps workers to identify the correct disconnect switch and to avoid accidentally de-energizing the wrong equipment. There are several different types of disconnect switches, each designed for specific applications. Some common types of disconnect switches include knife switches, fuse disconnect switches, and circuit breakers. Knife switches are simple, manually operated switches that use a blade-like conductor to make or break the circuit. Fuse disconnect switches combine a disconnect switch with a fuse, providing both isolation and overcurrent protection. Circuit breakers are automatic switching devices that trip and interrupt the circuit in the event of an overcurrent or short circuit. When selecting a disconnect switch, it is important to consider the voltage and current rating of the equipment it will serve. The disconnect switch must be rated to safely interrupt the maximum voltage and current that could flow through the circuit. It is also important to consider the environmental conditions in which the disconnect switch will be used. Disconnect switches that are used outdoors must be weatherproof and corrosion resistant. Regular inspections and maintenance of disconnect switches are essential to ensure their safe and reliable operation. Inspections should include checking for loose connections, damaged components, and signs of overheating. Maintenance should include lubricating moving parts and tightening any loose connections. By following these guidelines, facilities can ensure that their disconnect switches are properly installed, maintained, and operated, providing a safe and reliable means of isolating electrical equipment. Electrical safety practices are crucial for preventing accidents and injuries in the workplace. These practices include following established safety procedures, using appropriate personal protective equipment, and maintaining a safe working environment. Before working on any electrical equipment, it is essential to de-energize the equipment and verify that it is de-energized. This can be done by using a voltage tester to check for the presence of voltage on the equipment. Once the equipment is de-energized, it should be locked out and tagged out to prevent it from being accidentally re-energized. Lockout/tagout procedures involve placing a lock and tag on the disconnect switch or circuit breaker that controls the power to the equipment. The lock and tag should identify the person who is working on the equipment and should not be removed until the work is completed. When working on electrical equipment, it is important to use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. Safety glasses protect the eyes from flying debris and arc flash. Gloves protect the hands from electric shock and burns. Insulated tools prevent electric current from flowing through the worker's body. It is also important to maintain a safe working environment by keeping the work area clean and free of obstructions. This helps to prevent trips, falls, and other accidents. Regular training on electrical safety practices is essential for all employees who work with or around electrical equipment. This training should cover the hazards of electricity, the proper use of safety equipment, and the procedures for de-energizing and locking out electrical equipment. By following these electrical safety practices, facilities can significantly reduce the risk of electrical accidents and injuries in the workplace. The importance of regular inspections and maintenance of electrical equipment cannot be overstated. Regular inspections can help to identify potential problems before they lead to accidents or equipment failures. Maintenance can help to keep electrical equipment in good working order and to extend its lifespan. Inspections should include checking for loose connections, damaged components, and signs of overheating. Maintenance should include lubricating moving parts, tightening loose connections, and replacing worn or damaged components. It is also important to keep electrical equipment clean and free of dust and debris. Dust and debris can accumulate on electrical equipment and cause it to overheat. Regular cleaning can help to prevent this. Records of all inspections and maintenance should be kept. These records can be used to track the condition of electrical equipment and to identify any recurring problems. By implementing a comprehensive inspection and maintenance program, facilities can ensure that their electrical equipment is safe and reliable. The role of qualified personnel in ensuring electrical safety. Qualified personnel are individuals who have the knowledge, skills, and experience necessary to safely install, maintain, and operate electrical equipment. Qualified personnel should be trained in the hazards of electricity, the proper use of safety equipment, and the procedures for de-energizing and locking out electrical equipment. They should also be familiar with the NEC and other applicable electrical codes and standards. Only qualified personnel should be allowed to work on electrical equipment. This helps to ensure that the work is done safely and correctly. Qualified personnel should also be responsible for inspecting and maintaining electrical equipment. They should be able to identify potential problems and to take corrective action before they lead to accidents or equipment failures. Facilities should have a system in place to ensure that all electrical work is performed by qualified personnel. This system should include procedures for verifying the qualifications of personnel and for providing ongoing training. By relying on qualified personnel, facilities can significantly improve their electrical safety record. The potential consequences of neglecting electrical safety. Neglecting electrical safety can have serious consequences, including electric shock, burns, arc flash, fires, and explosions. Electric shock can occur when a person comes into contact with an energized conductor. The severity of the shock depends on the voltage of the conductor and the amount of current that flows through the body. Electric shock can cause muscle spasms, difficulty breathing, and even death. Burns can occur when a person comes into contact with hot electrical equipment or when an arc flash occurs. Arc flash is a dangerous electrical explosion that can cause severe burns, blindness, and hearing loss. Fires can occur when electrical equipment overheats or when a short circuit occurs. Electrical fires can spread quickly and can cause significant damage. Explosions can occur when flammable gases or vapors are ignited by an electrical spark. Explosions can cause serious injuries and property damage. In addition to the physical consequences of neglecting electrical safety, there can also be significant financial consequences. These consequences can include fines, lawsuits, and increased insurance premiums. Facilities that neglect electrical safety may also suffer damage to their reputation. By taking electrical safety seriously, facilities can protect their employees, their property, and their reputation.